Dear students, welcome to Chapter 5, Wind, Basics 1. Before I go into our class, I tell you a very small story. A farmer set forth on a journey, driving before him a horse and an ass, both well laden with some luggage, some sort of fertilizer, some organic matter, some seeds. Both ass and horse were carrying. The horse, as long as he traveled along the plain, carried much, almost 75% of the load with ease. But when he began to ascend the steep path of the mountain, felt his load to be more than he could bear. He entreated his companion ass to relieve him of a small portion, that he might carry home the rest. But the ass paid no attention to the request of the horse. The horse shortly afterwards fell down and dead under his burden. Not knowing what else to do in so wild a region, the farmer placed upon the ass the load he carried in addition to the load of the horse. The ass, groaning beneath his heavy burden, said to himself, "I am treated according to my destiny. If I had only been willing to assist the horse, then a little in his need, I should not now bearing this much of load." The saying is, an ounce of prevention is worth a pound of cure. An ounce of prevention is worth a pound of cure. Now, let's go into the class. Wind, Basics 1. The earth is enveloped by atmosphere, thereby air. The air has weight. So, the pressure exerted by the air is the greatest at the bottom. The pressure decreases with height above the surface of the earth. Air in its horizontal motion is known as wind. This bit will come. Air in its horizontal motion is known as wind. Air in its vertical motion is known as air currents. Horizontal motion is known as wind. Vertical motion of air is known as air currents. Winds are named by the direction they come from. The term windward refers to the direction the wind comes from, and leeward is the direction to which the wind flows. Again, for your academic benefit, once again, even from the examination point of view, I would like to repeat once again. Windward refers to the direction from which the winds come from, and leeward is the direction towards it flows. Air in its horizontal motion is known as wind. Air in its vertical motion is known as air currents. The wind which flows more frequently from only one direction than the other is called prevailing wind. The wind which flows more frequently from one direction than any other is called prevailing wind. Wind speed increases rapidly with height above the ground level because the frictional drag decreases. Because of the frictional drag of the surface, okay, the wind speed increases rapidly as the height increases above the ground level. Now, usually the wind can be observed in its undisturbed state only at very high levels. Therefore, there is a diurnal. Diurnal means day and night. The diurnal variation of wind speed at various levels occurs. For example, at the lower levels where crops are grown, there is a daily sequence with a well marked maximum around noon and minimum by night. Okay. Wind speeds are usually maximum around noon and minimum by night. Whenever a farmer wishes to spray a chemical, to the extent possible, he should not choose afternoon because wind speeds are high. So, whatever the chemical he is spraying may get blown away. Now, the importance of wind on croplands. Importance of wind on croplands. Wind performs several functions which are of paramount importance in agricultural activities. Wind transports heat in either sensible or a latent form from lower to higher latitudes. Sensible means the energy utilized in heating the air. Latent heat means the energy utilized in evaporation and transpiration together. So, wind transports heat in either sensible or latent form from lower to higher latitudes. Wind provides the moisture which is necessary for precipitation. Moderate turbulence promotes the consumption of carbon dioxide in photosynthesis. Wind prevents frost by disrupting a temperature inversion. Temperature inversion means instead of fall of temperature as the height increases in the troposphere, under certain specific conditions the temperature increases. This is called as temperature inversion. We discussed in the air temperature chapter. Now, the wind dispersal of pollen and seeds is natural and necessary for certain agricultural crops, natural vegetation, etc., etc., etc. The action of wind on soil is by two ways. Wind causes erosion in two ways. In other words, strong wind blows loose and coarse soil particles and dust for long distances. In some areas, a large quantity of soil is blown by this way, and cultivation of crop is not possible in such areas where strong wind blows loose and coarse soil particles, which is essential for crops to get established, crop seeds to germinate. Now, the second action of wind on soil is in dry countries and seashores. Strong wind is seen to eat up a cliff or a hard rock. One strong wind armed with millions and millions of small particles of sand flows against a cliff or a hard rock. It gradually eats up the rock. The action is strongest near the ground so that the rock is undercut and eventually falls over. So, this is the importance of wind on croplands. Wind transports heat, provides moisture, provides moderate turbulence. Wind prevents frost, wind dispersal of pollen, and wind action of soil erosion. Now, the basic laws of gases is basic laws of laws you should learn to understand the wind motion and the optimum use of wind or air for our agricultural purposes. Here also I have taken care that neither mathematics nor basic physics is too much involved. Simple physics only, basic laws of gases. Kinetic theory of gases is one of the established theories to explain the behavior of gases. Therefore, based on the kinetic theory, I just give you 5 to 6 important points with reference to basic laws of gases. All the gases are composed of molecules. The molecules of a particular gas are all alike and differ from the molecules of other gases. The molecules are mere point masses. Their dimensions are negligible as compared to the distance between them. The molecules are continuously in motion. They have velocities in all the directions ranging from 0 to infinity. The velocity of the molecules increases with the temperature. In a steady state, the molecules are continuously colliding against each other and also with the walls of the containing vessel. Between two collisions, a molecule moves in a straight line and the distance is called free path, F-R-E-E, free, P-A-T-H, path, free path. Of course, the collisions are instantaneous. In a direct impact, the molecules begin to move in the opposite direction with the same velocity. So, these are the basic laws of gases explained the most accepted by the scientists theory, that is the kinetic theory. All gases are composed of molecules. Molecules are mere point masses. Molecules are continuously in motion. In a steady state, the molecules are continuously colliding against each other. The collisions are instantaneous. In a direct impact, the molecules begin to move in the opposite direction with the same velocity. These are the basic laws of gases explained through kinetic theory. So far, we tried to understand what is wind. Air in its horizontal motion is known as wind. Air in its vertical motion is known as air currents. The wind which flows more frequently from one direction than any other is called prevailing wind. The wind can be observed in its undisturbed state only at very high levels. However, at low levels, there is a daily sequence with a well-marked maximum in the noon and a minimum by night. The importance of wind on croplands, like transports heat, provides the moisture, moderate turbulence promotes consumption of carbon dioxide in photosynthesis, wind prevents frost, wind dispersal of pollen is essential, action of wind through erosion. After that, we just learned a minute back basic laws of gases. Now, we move on to factors affecting the wind motion. There are 4 forces which affect the wind motion. The first one is the pressure gradient force. Second one is the Coriolis Force. Third one is the Centrifugal Force. The fourth one is Frictional Force. These forces are very interesting. Again, I would like to impress upon you that neither physics nor too much of geography involved. Of course, no mathematics. I just try to explain in a very simple way. Pressure gradient force is the force is given by pressure decrease per unit horizontal distance and acts in a direction particular to the isobars. Isobars are the lines drawn connecting the points of equal pressure. Okay. Now, the pressure gradient force tends to drive the wind towards the low pressure or air towards the low pressure. Pressure gradient force is, this force is given by pressure decrease per unit horizontal distance and acts in a direction perpendicular to the isobars. This is pressure gradient force. The next one is Coriolis force. This force is due to the rotation of the earth. This bit will come in your midterm, maybe in theory final exam. Coriolis force. This is the force which is due to the rotation of the earth. Rotation of the earth, fill in the blank may come, rotation of the earth. In the match the following may come, then you should tick at the Coriolis force. Okay. Now, so Coriolis force is due to the rotation of the earth. The Coriolis force causes all winds in the northern hemisphere to move towards the right, and those of the southern hemisphere move towards the left with respect to the rotation of the earth. At the equator, this bit again will come, this is a very important point. At the equator, the Coriolis force is 0 and it is maximum at the poles. Once again, for your academic interest from examination point of view, I read. At the equator, the Coriolis force is 0 and it is maximum at the poles. Another important bit as far as Coriolis force is concerned, Coriolis force is due to the rotation of the earth. Now, after pressure gradient force, Coriolis force, let us try to understand what is centrifugal force. When an air particle travels in a curved path, an acceleration towards the center of the rotation is resulted. Due to this acceleration, a centrifugal force operates and makes to throw the particle outward radically. Okay, when air particle travels in a curved path, an acceleration towards the center of the rotation is resulted. Due to this acceleration, the centrifugal force operates and makes to throw the particle outward radically. This is known as centrifugal force. Just like when you skim curd and put water and skim, the centrifugal force acts. Similar way, when air particle travels in a curved path, the same thing happens. Of course, the frictional force in day-to-day life, we always observe while walking, while moving, what not. In every walk of our life, we experience the frictional force. What is that? The roughness of the surface provides frictional resistance to the air. When we are walking on the road with our own shoe or chappals, the frictional resistance only makes us to move from one step to other. Same way, the roughness of the surface provides frictional resistance to the air motion. This force acts in opposite direction and reduces the wind speed. Okay, this force reduces the wind velocity. In other words, it reduces geostropic and centrifugal forces to give resultant in the direction of a pressure gradient. The winds are turned towards low pressure and flow across the isobars. The winds are turned towards low pressure and flow across the isobars at an angle of 15 degrees on the sea, but around 30 degrees on the land due to high friction offered by the land. because sea offers less friction. Only at 15 degrees centigrade, at 15 degrees angle it moves, and on the land at 30 degrees because of the friction. Now, these are the factors affecting the wind motion: pressure gradient force, Coriolis force, centrifugal force, frictional force. Now, a very interesting small subtopic of today's class is Earth's surface wind systems or wind belts. Earth's surface wind systems. Very interesting. In a very simple way, I try to explain this. What are these? Doldrums, trade winds, also known as tropical easterlies. This bit will come in the midterm. This bit will come in the theory final. Doldrums. Next one is trade winds. Trade winds are also known as dash. Okay, tropical easterlies. The third one is prevailing westerlies, and the fourth one is polar easterlies or polar winds. In a very simple way, I try to explain. The wind belts found on the Earth's surface in each hemisphere. Each hemisphere means northern hemisphere, where most of the land is present. That's why the northern hemisphere is known as land hemisphere. The southern hemisphere is known as water hemisphere. Now, the wind belts found on the Earth's surface in each hemisphere. These are, once again, for your academic interest: doldrums, trade winds, prevailing westerlies, polar easterlies. What are doldrums? Owing to or presence of continuous heating of the Earth by insolation, incoming solar radiation, heating of the Earth by insolation, pressures are low and winds converge and rise near the equator. This intertropical convergent zone, ICZ, expand the following, you get a bit like this: intertropical convergent zone, ICZ. This is known as doldrums. Once again, I will tell. Owing to continuous heating of the Earth by insolation, pressures are low and winds converge and rise near the equator. These are known as doldrums. These doldrums are equatorial belts of calm and variable winds. The location on the Earth is 5 degrees south and 5 degrees north latitudes on both sides of the equator. Wind is light due to very negligible pressure gradient. Mostly there are vertical movements in the atmosphere. The atmosphere is hot and sticky in doldrum areas. Now, the second one is trade winds. These are also known as tropical easterlies. Third time I am telling, this bit will come in the midterm. This bit also comes in the final theory examination. Trade winds are also known as tropical easterlies. The equatorial low is known as doldrums. Good. Now, what are trade winds? The regular high temperature at the equator, as I said in the doldrums while explaining, the regular high temperature at the equator results in a high pressure forming in the upper levels. There is a low pressure in the lower levels, therefore a high pressure forming in the upper levels over the equator. Then the air is transferred to the northward and southward directions until 35 degrees north and south in both the hemispheres. That means while solar radiation heating the air near the equator, the earth is rotating, thereby the air which has risen near the equator is transferred to the north northward and southward directions until 35 degrees north and south in both the hemisphere. That means from equator to 35 degrees north, from equator to 35 degrees south latitude. Degrees means degrees latitude. Okay, in both the hemispheres. Due to this reduction in surface pressure on the equator, there is a reduction in surface pressure on the equator. That's what we call it as the doldrum. There is an increase in the pressure at 35 degrees north, 35 degrees south, which are known as horse latitudes or subtropical high. These are known as horse latitudes. From the equator, winds rises travel up to 35 degrees latitude in both the hemispheres. These are known as horse latitudes. So, as a result, the winds flow from horse latitudes to the equatorial region. While moving, these winds are deflected by Coriolis force, as I explained in the factors affecting the wind motion. There is a Coriolis force, it is due to rotation of the earth. Now, as a result, the winds flow from horse latitude to the equatorial region. Of course, while moving, these winds are deflected by Coriolis force because of the rotation of the earth to the right in the northern hemisphere and to the left in the southern hemisphere. So, these winds flow from both sides of the equator, both hemispheres, okay, 35 degrees north to the equator. These winds flow from 35 degrees north to the equator in northeast direction in the northern hemisphere, and from 35 degrees south to the equator in the southeast direction, okay, in the southern hemisphere. Therefore, these are known as trade winds because winds are almost calm. Here, these are also known as I said, 4 times tropical easterlies. Okay, once again, for your academic interest, the winds flow from 35 degrees north to the equator in the northeast direction in the northern hemisphere, and from 35 degrees to the equator in the southeast direction in the southern hemisphere. Okay, these are known as trade winds. Of course, the name is given by some traders who found when they are traveling with trading material across the seas, while traveling over the sea, they were observing their ships moving in effortless, with calm in certain areas of the water or seas or oceans from one continent to other continent. So, while they were carrying these trading material in their ships, they found wind directions only in one, almost predominantly. So, these winds they named as trade winds because they were spending less energy or efforts, and their ships were moving freely because of these winds. They named it as trade winds or tropical easterlies. Now, scientists made it tropical easterlies, traders made them as trade winds. Now, what is the term anti-trade wind? It's very simple. This is a supplementary wind system of the earth which is effective at higher levels, not at the surface. The trade winds are upper winds, okay. The trade winds are a surface in general. The anti-trade winds are supplementary wind system of the earth which is effective at higher levels. Anti-trade winds are higher levels, trade winds are surface levels. Now, there are some differences between trade winds and anti-trade winds. From your examination point of view, I just try to explain the differences between trade winds and anti-trade winds. Trade winds and anti-trade winds. Trade winds are surface air currents that move towards the equatorial belt. Anti-trade winds are upper air currents. This bit will come, differences also will come. So try to understand. I am trying to explain once again. Trade winds are surface air currents. Anti-trade winds are upper air currents. Trade winds flows from, I explained to you a minute to 2 minutes earlier. Trade winds flows from northeast in the northern hemisphere and from southeast in the southern hemisphere. Of course, anti-trade winds flows from exactly reverse, southwest in northern hemisphere and northwest in southern hemisphere. The movement is constant and steady throughout the year for trade winds. That's why the traders were able to take the advantage. Movement is constant and steady throughout the year. Of course, anti-trade winds, the movement is not constant throughout the year. Again, the trade winds are very good and quiet. Because the weather is quiet, trade winds results quiet weather. Of course, weather is disturbed for anti-trade winds. Several times I told, trade winds are also known as tropical easterlies. Anti-trade winds known as prevailing westerlies, which I am going to discuss with you as third factors, okay, or Earth's surface systems, prevailing westerlies. Now, trade winds and anti-trade winds, these are the differences. The anti-trade winds are also known as prevailing westerlies. What are prevailing westerlies? After doldrum, after trade winds, the third one is the prevailing westerlies. The winds that flow from subtropical high to the low pressure areas at about 60 to 70 degrees latitude in both the hemispheres are known as prevailing westerlies. Very interesting, very interesting. Equator, there is a doldrum. When winds rise because of high insolation over the equator, the winds move 35 degrees north, 35 degrees south on both sides of the equator in both the hemispheres. However, at about 60 to 70 degrees, these prevailing westerlies, 60 to 70, 60 to 70, 60 to 70, okay, the prevailing westerlies present are the winds that flow from subtropical high to the low pressure areas at about 60 to 70 degrees latitudes on both the hemispheres are known as prevailing westerlies. These have got some significance. These winds are forceful and are irregular compared to trade winds. These have got a good significance with reference to rain occurring in the winter season in the temperate region. Okay, this is the basic course. In the advanced course at the PG level, I try to cover. Now, the fourth one is the polar easterlies or polar winds. A permanent high pressure exists on the poles. Permanent low pressure exists on the equator doldrum. Permanent high pressure exists on the poles, which is known as polar easterlies or polar winds. From these high pressures, cold winds, not warm wind, from these high pressures, cold winds flow to the areas at about 60 to 65 degrees latitudes in both the hemisphere. That is where the prevailing westerlies are there. Okay, the winds flow in northeast direction in the southern hemisphere, exactly opposite, and in southeast direction in the southern hemisphere. So, the polar easterlies are permanent high pressures. These are the pressures which from high pressures cold winds allowed to blow to the areas at about 60 to 65 degrees latitudes, 60 to 65 degrees latitudes, almost like our prevailing westerlies what I explained a minute back. So these are the 4 surface Earth's surface wind system or wind belts: doldrum, trade winds, prevailing westerlies and polar easterlies. Thank you.